Because the Earth is rotating, the Earth is spinning. That's what makes the sun appear to rise and set, and that's what makes the stars appear to move. Exactly. Okay. So this ghostly looking thing, kind of that, okay, that's the model called the celestial sphere. Now, are the stars really that just kind of equidistant from the Earth? No. Do the stars really orbit the Earth? No. Although they used to think the stars orbited the Earth. But this is kind of showing you that the celestial sphere rotates or appears to rotate with the Earth in the center. Okay? And it's kind of showing you direction. And it hurts my brain to think, well, if we look up, this is actually why we see the stars going counterclockwise around the North Star. All right. So now, if you get your bearings here, what they've done is to put somebody, not at the North Pole, kind of, we're about, what do we say, 42 or so degrees latitude from being 0. You guys told me 0 was the equator. You go up 42 or so, and that's kind of where we are, about 42, 43, 44. Okay, so here we have a person. The sun is... I think I got this right. I'm going to put the sun over here. Okay. So do you see where that's daytime? Okay. And this is night. I don't think I got that right. I mean, I do have that part right. No, that's not what I want to say. This is what I want to say. Say this person can see stars over here, okay, and forget about the daytime, nighttime, where the sun is. Can you see where the stars that this person can see are, where the white part is? So this person can see all of these stars. I wish I picked a different color. I picked red. This person, as the Earth spins on its axis, forget daytime, nighttime, that person can see from horizon to horizon, okay? And how is it spinning? Well, it's spinning around the axis of rotation, and these are the stars this person can see. It's limited, okay? Put another way, and I think I have a picture coming up here. I'm going to choose green, and I'm going to put a person here. That little green thing is that person there. Again, go from horizon to horizon. And as the Earth spins now, that's the kind of dome of stuff that person can see. You move towards the equator, and your dome of stuff that you can see is different. If you move at the equator, let's choose, it's getting really messy. I'll clear all the strokes away. If you're at the equator, this is, I'm going to put somebody at the equator. We're going to actually see some tropical trees here in a minute. Do you guys buy this? That this is what the sky that the person at the equator can see. Why? Because you look horizon to horizon, Earth is spinning on its axis, and that's what you're going to see. Okay, so that's how that kind of works. So there are certain stars in the southern hemisphere that we're never going to see, okay? Another thing about this is there are certain stars, I'll clear this. I think this is clear all strokes. The term is called circumpolar stars. So do you see where this up here, everything going up, where I have purple there, those are what we call our circumpolar stars. Those will never set below the horizon, and it's different by what location you are. Okay? I'm going to go ahead and switch to the polar bear. A minute ago, I said if you were a person standing right up here, I said, this is what your sky looks like. Check this out. Actually, all of your stars are going to be circumpolar. If you're at the North Pole and you point to Polaris, where are you going to point? Straight up. Yep. Okay. So the cool thing about circumpolar stars are basically there are a bullseye of stars that basically meet the horizon. So if it's straight up, think of a bullseye, 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 bullseye in all directions. Okay, so that's kind of what that looks like. Okay. I think so. Circumpolar stars are stars that never set. So I have a couple of slides here. I've mentioned that, I have one of those, when I take pictures, I've got one of those tripods that keep up with the rotation of the Earth. Yeah. And so one of the things I can do, is this right? No, that's not right. I turn that feature off. So when I want to take star trail pictures, I turn that feature off. My tripod is not rotating. And then what I do is I go ahead and I take a picture, okay, and then maybe 10 seconds later I take another picture. 10 seconds later I take another picture. But I'm letting my camera, my camera's not moving, I'm letting the Earth move. Yeah. Okay, yeah, letting the Earth move. And then there is a program, anybody can get it. If you type in Star Trails Photography online, it's free. There's a program out there to go ahead and take those pictures I took that were 10 seconds apart and basically kind of, they don't stitch them together, but they kind of stitch them together and they draw a line to connect where the star has moved. Is that not cool or what? That's free out there. It's making your own star trails. I know. So all you got to do, and you don't need anything with your tripod, just take a normal camera, take a picture of stars, wait a little bit, don't move your tripod, take another picture of the stars and they'll move, take another picture of stars and they'll move, and then you have to just download that program and feed them into that program. I know. Isn't that fun or what? So there's my star trails. Here's another one, and that one actually is trying to get the bullseye. I thought that was fun, you know, right? This one actually, I didn't center on Polaris. I just kind of, where I thought some pretty stars, I kind of took, you know, picture a little bit apart. Get that. So yeah, oh, pretty. Okay, so these are some figures from your textbook. Okay, so remember the difference between a figure and a picture, right? A photo, when I say picture, I mean photo. So this is a figure. We got the polar bear thing going on. You guys told me, if you're at the North Pole, you guys told me Polaris is right overhead. So if he was going to take a star trail photo, okay, he would look down and he would basically see, he would see the stars have a circle here, going counterclockwise, star trail, circle, circle, circle. But by the time you get to the horizon, all he's got is lines, okay? So lines horizontal. I think that's kind of fun. Here's if you were at the equator. Okay, so that's the pole. Now, over here, I'm going to go to the equator. So where is Polaris if I'm at the equator? Yeah, the Polaris is actually, maybe, it's on the horizon. Polaris is on the horizon. Okay, so here I am. Here, you guys told me Polaris is here, right? Right? Okay, so what if I am at the equator? Okay, Polaris is on the horizon. Okay, yeah. Exactly. I know. So what they've done here, so if I were to look this way towards Polaris, I'd see a half a circle, another half a circle getting bigger, half a circle, with Polaris right there, half a circle. Okay, if I looked either due east or due west, basically, I would see stars going like this. Okay, and then heading towards this, I made this south this time, half a circle, half a circle, half a circle. So that's the star trails there. I think that's fun. And this is kind of what the star trails would look like in our neck of the woods. They're kind of slanty. Slanty with the horizon. As long as you're not looking at Polaris. So we talked about the term in your local sky, the term zenith. Okay, that's straight up, okay, with the horizon. Everybody has their own zenith. This person is standing at the North Pole. Okay. So I already kind of said that kind of white, that kind of light color is where the stars that person can see, or the sky that person can see as the Earth spins. Now, where's this person standing? They're on the right. Which hemisphere is he or she in? Southern, yeah, southern hemisphere. So go out kind of in all directions to the horizon, and can they see the North Pole there? No, they can't see the North Pole. Do you guys remember we talked about this, I think a little bit. So is there a star? Is there a star if you take the south axis of rotation and point out to the celestial sphere? Is there a star down there? Nope. No. Yep, you got it. Okay. So this was the figure I'm hoping that we can look at to maybe even help us tonight or Sunday if we're looking at stars, find the Big Dipper. I don't know. So the Big Dipper is this one down here. Now, in order to, we have the Big Dipper here, and we have the Big Dipper here. Why is it shown twice? Because the Earth rotates. They're showing it certain hours apart. Exactly. So what your author has done is kind of shown it 2 hours, 4 hours, and this is 6 hours from the position A. So between A and B, we have 6 hours. Okay, what direction is it going? Counterclockwise, yes. You got it. Okay. So now shown here is how we find the little Polaris. So what do we call these stars right here? In the Big Dipper. Remember what we call those? They're in the bowl. The farthest 2 bowl stars are called, that starts with the letter P. They're called what? I think so. Pointer stars. Pointer stars, exactly. And so they are pointing at Polaris. And so Polaris is right there. Are the pointer stars down here pointing at Polaris? Yeah. So that's kind of how that goes. The Little Dipper is is the Little Dipper moving? If we call this A and B, is it rotating too? Yep. But does Polaris move? No. So it just kind of swings around on the handle. I know, you're like, ah. And it's fun to kind of prove this to yourself. You know, if you're out long enough, you're like, oh, you know. Very good. Well, we already said, oh, this is important. And I mentioned this before. So the clock in here is Polaris. I'm going to go back to kind of what we said. Okay. So, and you talked about people being able to use the North Pole for navigation. So if you put out your hand, okay, and see what angle that makes with the horizon and Polaris, that angle is your latitude. Mm-hmm. Yep. Because you guys told me that Polaris, if you're at the North Pole, Polaris is straight up. Okay, so what angle is that? 90, yeah. And if you're at the North Pole, you're at 90 degrees latitude. If you're at the equator, what angle does Polaris make with the horizon? Where is Polaris if you're at the equator? Yes, if you're at the equator, and I kind of switched gears, I made this mine. If you're at the equator, Polaris is right on the horizon. Okay, so what angle is that? 0. 0, yeah. So if you get kind of confused, think of those two extremes. Polaris is up here if you're at the pole. Polaris is here if you're at the equator. And we're somewhere in between. So that's our latitude. So as sailors would at least go north and south of the equator, they would get a fix for how far they've gone with their latitude. Okay. So in the southern hemisphere, you guys told me there is no pole star that our southern axis of rotation is pointing to. So the best they can use, or a good thing that they can use, is this little constellation called the Southern Cross. Do we have a Northern Cross constellation in our hemisphere? Yes, we do. Some constellations have more than one name, and actually the Northern Cross, the old-timey name was called the constellation Cygnus. So Cygnus the Swan, the Northern Cross, they're the same thing. Okay, so actually, grab your little sheet thing. Is it up? The way I find Cygnus on the sky map is the way, and it might be kind of go back to some of the stories about the constellation Cygnus, is that Swan is flying up the Milky Way. So if you find the Milky Way, you can probably find Cygnus if it's out. So there's the Northern Cross. Okay. On my list of things to do one day is to go to the Southern Hemisphere and to look at their stars. I know, I got a whole list of things I want to do. I need time and money. Let's see. Oh, that isn't what I want to do. The next thing we already kind of talked about a little bit. And students usually probably kind of buy into this pretty well. Oops, resume slideshow. It's not wanting to. That's a new one. There we go. Okay, so we're going to kind of switch gears a little bit. Instead of going to the day thing, we're going to go to the year thing. And this is my son, okay? And all this is kind of trying to convince you of, and you guys are already kind of, I'm sure, by this, okay, is that we see, if that's the sun, okay, these guys are seeing the stars, right? Okay, so I'm going to go ahead, and I don't know if you guys can, I'll exaggerate what this tilt is. Anytime you buy a globe like this, it doesn't sit straight up, it sits kind of slanty, and the slantiness is showing you the tilted axis of rotation. So I'm going to go ahead and make sure my tilt is towards Polaris. Okay, so we see different stars over here, okay? Then we do, how long does it take? I'm going to go halfway around. Okay, we're going to talk about this a little bit, okay? I'm going to go halfway, okay? So how long was that? 6 months. That was 6 months. Very good. And then go back over here. No, 6 months. And the day thing is like this. So we do one of these in 24 hours. It is confusing.
Except for those two. The spin is 24.
It is. The spin is 24 hours. And so how much is, I'm going to go quarter. How long is this?
3 months.
3 months. Very good. There's another. Then this is 6. Okay, so how many months is this?
9.
9. Back to the, yep. I tried to kind of keep it. So we see different stars over here. Then we do 6 months later. Our nighttime is over here. Okay.
But do you see the same stars over there the next year?
Yes, we see the same stars over there the next year. Perfect. Yes. It's because basically, you know, we talked about the model of a celestial sphere. You know, we kind of think stars are close, but stars are way far away. So instead of kind of the celestial sphere, think of basically our solar system as being, there's this humongous set of stars that we're kind of going like this amongst this humongous set of stars that generally don't change. Yeah, that's neat. And so if you're like a zodiac, or if you're like a astrology person, and don't feel bad if you call this class astrology, because you're in good company. It's not, okay? But astrology, what they do is, as they basically say, where is the sun? What set of stars is the sun passing through? Okay, so basically, in other words, like over here at nighttime, I see these stars. If we didn't have a blue sky, and if our sun weren't so bright, which I'm glad it is, we could actually see stars over there. They're up there. In fact, if you have an app on your phone, you can hold it up in the vicinity of the sun and you can see the stars over there. So wherever the sun is passing through those constellations, passing through, right? It's not really passing through those stars, it's just kind of passing through against those background stars. That is how your zodiac sign lines up. Okay, now this is where I get people like mad. Okay, I don't know. I don't mean to make you mad, but don't blame me. Okay, so there are, is it 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, okay, so 12 signs, okay, of the zodiac. And those signs are all about where the sun is passing through. Now I'm going to go back to this one. The problem comes in, let me find it, right here, Ophiuchus. Okay, people are Leo, Virgo, Libra, Scorpius, Sagittarius. Okay, those you all are, those 12. But nobody that you know of, and actually I am one, I guess, an Ophiuchus. And I'm not sure why it was left out, but literally the sun does pass through that constellation. So it's almost like the astronomers and the astrologers. Who do you believe? Okay. So this is to say that actually there's a 13th sign, constellation. Yeah, I know. And don't let it get you down.
Is that why those all have different dates than what they want?
Yeah, I was confused.
Yeah.
I know. Feel free to. There are things in this. Most things in this class you cannot ignore. You can ignore this slide if it really bothers you.
Yeah, they totally left out a constellation. It's like,
I know.
Why did they do that?
So
So why are
I'm not
those
sure.
dates different?
why do the dates change a little bit?
Yeah, why did they? Because you gotta fit in that.
Yeah, because you got to fit in a 13th one, so they all kind of juggle a little bit.
Very interesting.
I don't know, but don't let it ruin your day. Okay. So days. I don't know. Does anybody in here have an Alexa at home that they? Yeah, I love Alexa. No, Alexa. Oh my gosh. Well, when you're old and have more money than you need, you can buy an Alexa, and you can ask Alexa jokes, or you can. We use it for a shopping list. The older you get, the more you need lists. Okay.
She tells bedtime stories too.
She tells bedtime stories. I did the whole singing a song. Oh, that was so cool. But one of the things you can ask Alexa is how many days till spring. And I think we're at, it was 60, 59, might be at about 58 days till spring. Oh, yeah. So are the days, what do we got going on with the number of daylight hours? Are they increasing or decreasing now? They're increasing, yep. Daylight hours are increasing. Ever since the winter solstice, now we're getting longer and longer daylight hours, okay? And that actually is one of three main reasons why we're getting warmer, okay? Because we have more sunlight, hours of sunlight. So I need to actually kind of talk about why we are going to get warmer. Spring's going to be warmer. Summer's going to be warmer yet. Okay, and then we're going to transition from summer to fall, and it's going to start to get cooler. Fall to winter. I love spring's my favorite season. Okay.
that's because our orbits get closer to the sun.
No. And a lot of people think that. They think because the Earth gets closer to the sun. And here's why. I've heard described why that's not the case. Do you guys, I'm going to go ahead and bring up, this is the Earth obviously, and my stool there is the sun. I'm going to go ahead and tilt it, okay. Now this actually, and maybe this is what you're saying. So yeah, there might be some validity in what you're saying, Ty. So here we go. It seems like we're kind of tilted towards the sun. When I say we, I mean the northern hemisphere, and it's all about us, isn't it? Okay. So, but the southern hemisphere, what's it relative to the sun here? This is summer. It's tilted away. So, southern hemisphere, if my finger is the equator, it'd be tilted toward, tilted away. So yeah, we get summer, they get winter, okay? And then you guys told me this is now watch my tilt, okay? And I wish I could see how the tilt went?
Oh,
Yeah, you guys told me this is 6 months. Okay, so now, what do we got tilted away? The northern hemisphere. Yeah, so this is our winter, 6 months later. Yeah, exactly. And they got summer down there. So yeah. So that's kind of how that works. So the tilt actually, and I've had students say it seems like we're literally closer, or they're closer here, and we're farther away. But it's not the length of space between the Earth and the sun that makes that difference. Okay? All right. Very good.
I have a question.
Uh-huh.
So when we go around, you said something about okay, we go around the sun and it's like an oval shape. So
Yes.
when we're closer, like on the side, is it warmer? Or does that mean anything?
Yeah. So, and this is going to be on a slide coming up later, but, okay. So, let's see. Yes. I think I told you that, it's not a circle, it's an oval. I'll go ahead and do it here. made it darker. Here's my oval. That's how the path that the Earth takes. I'm going to go ahead and draw my sun off center. Okay? Oh, let me go ahead and draw it over here. This is my sun off center. An oval is called an ellipse, okay? And one cool thing about ellipses is they have two belly buttons, kind of like eyes. They call them foci. And anyway, the sun is at one foci. So anyway, so it's not this far askewed, but it is kind of. Okay, over here, we're going to call that perigee. Perigee. And I'll take a picture of this and throw it out there on Twitter. But that's perigee. Like if you parry somebody, you do the, yeah, you're close. And this is called apogee. Apogee. We're farther from here, okay? This is where the Earth is here, 6 months apart. Okay? I'm going to tell you that perigee actually has come and recently gone. This is January 4th every year. January 4th. What do you think? We're feeling kind of the whole, were you feeling the heat thing on January 4th?
Yeah, that's what I was like,
Turned away, we must.
Yeah. January 4th was about here. Okay. And then some people, and I've wondered this myself, I'm like, well, so these guys get summer at perigee, so are they toasting down there?
I was like,
And then it gets confounded, it's complicated, but like one of the things about the southern hemisphere is they have more water, and that actually can kind of moderate their temperatures a little bit. So I know, it's like a wet meteorology thing. So, and this is, let's see, January 4th. This is July something. July, let's see. December 25th, 6th, June 25th, July 4th-ish. Wow. I don't know. We'll have to look that up. Okay, so it's not a distance thing. So,
So they think because of the tilt is why we have,
and I'm going to try to convince you of that, but we're all probably good about, do you guys buy this that, actually, what season is this? What season is this for us? Sorry.
Summer.
This is summer, exactly. Okay? And the way it works is that as the Earth does one day, like 124 hours, okay, if you are south of 66 and a half degrees south latitude, you have no daylight. Vampires migrate here. Okay? It's all dark, okay? And if you are north of 66 and a half degrees north, once the Earth spins, the sun never sets. That really hurts my brain. Okay, so that's kind of how the daylight goes. Now, I'm going to go right here, a quarter turn.
but you rotate
yeah.
Yeah, I'm gonna
if the
spin,
Earth
yeah.
rotates, why would
What's
they
that?
would get the same amount of sunlight every day, right?
Over here?
Yeah,
with the
and vice versa, right?
Here, no.
because
The-
angle.
Yeah.
Yeah, this is a little bit different.
So I'm going to go ahead and take my, let's see, how do I do this? Okay, I'm going to go ahead and go with the tilt. I'm tilted like this. You basically have a shaft. The sun can send a sheet of paper of energy. Here's my sheet of paper of energy, okay? And it actually stops here. It doesn't go south of 66 and a half degrees south latitude. My sheet of paper, it's like up here, and it stops here. That's where my sheet of paper of light is. So as the Earth spins 24 hours, counterclockwise, okay, this is in darkness.
But the next day it'll be in light.
Well, no. So what happens then is I'm going to go here a little bit. Now you can't see my finger, but the lightness extends a little bit further. Okay, I'm going to go over here. The lightness extends a little bit further. Bless you.
Thank you.
And I'm going to go right here. I'm going to go at a right angle to where I was before, which you guys would probably tell me 3 months. Does that sound right? Okay. At 3 months, okay, my sheet of paper of light from the sun basically fits both hemispheres evenly. It basically covers everything. And so as the Earth spins, at this place, 3 months from that was the winter solstice. This would be the spring equinox at the, we're coming up on that. What, 58 days, I know. Here, as the earth spins, all locations now get 12 hours of light. Okay, now as I go over here, okay, is this right? Yeah, as I go over here now, I've got a full sheet of paper down here, and I'm starting to get a crown up here that as the earth spins, there's no sunlight. And if I go over here to extreme, this is winter, December 21st, our winter solstice. Again, now we have a sheet of paper. It extends from about down here to up here. As the earth spins for a day, these guys don't get any light. So now we just switched.
Okay, so
Yeah.
does that tie in, okay, so Alaska.
Alaska.
When there's like only so many hours of
Yes.
daylight in, is it the whole year or just a specific season?
Yeah, so Alaska.
Is that the same for every other country in the same
The
latitude?
closer you get to up here, the more crazy your whole, as the earth does a year thing, the more crazy your daylight hours become. If you're at the equator, you're pretty solid with your daylight hours are pretty equal throughout
So
the
like it's
year.
kind of the same with
And they get extremes.
Russia.
So does that mean Earth has like a wonky orbit around the sun, kind of?
No, nope, it has a nice plane of the ecliptic, and it just, and I know it looks like I've been being wonky here, but it just is nice and smooth, and so now as I leave, what is this, winter, go to spring, okay? Now more and more of this that didn't have light is getting more and more light. I get over here, I'm at another place kind of across from where I was before. This would be the spring equinox, so we have a sheet of paper basically covering the whole earth. Okay, and then I go 3 months over here, and then I'm starting to get kind of shadowed here. And like you said, if you live near the poles, Alaska's close to the poles, then your daylight hours and nighttime hours have more extremes. So, I know it hurts my ears.
So when we go, like when we get to winter or whatever, is that just like a cooling process for the Earth?
It's a cooling process for our hemisphere, yep. And the southern hemisphere is heating up. So I think I have one more slide here. Go ahead, and this slide, we'll kind of end on this slide. But what this slide does is tell you exactly what I was telling you a minute ago. I want you to know for this class, I want you to know 4 important times of the year. And I went ahead and I'm making them north hemisphere centric. But I tried to kind of convince you that as the north hemisphere has winter, the southern hemisphere is having summer. Okay, so I went ahead, and I can never remember 21st, 22nd, 23rd. So as long as you know the month, you're in good shape. I know. So we would say that the winter solstice, this is the winter solstice over here. Okay, that's about December 21st through the 23rd. Okay, 3 months later, December, January, February, March. Okay, we're here. We're at one of the 2 equinoxes. Okay, I can never remember vernal, so I call it the spring equinox. And then 3 more months over here. Okay, we are June 21st-ish. Okay, this is a summer solstice. So the solstices are extremes, and the equinoxes are kind of in between. And then 3 months later here, we have our autumnal equinox, and that is in September. Okay. Is there any questions? I know. This right here, this kind of goes back to the Alaska thing, okay? There are times beginning, let's see, make sure I get this right. So this is spring, okay? So there are times, Alaska is getting more and more daylight too, okay? But they are actually going to get it, I want to say, quicker. There are ways you can go on the internet and find out how many daylight hours each location has, okay? But there are times then, since they are north of 66.5 degrees latitude, which is kind of a dotted line on here, or anyway, then, yeah, here it is. Then there are times when the sun never sets, and that's actually what this figure is showing you. Where is the sun throughout the course of a day? It didn't set. Okay, I know, it never set. Okay, so we didn't get all the way through chapter 2, but chapter 2 is due today, and chapter 1 is also due today. And then we'll pick up here on Monday. Okay? I do check my emails throughout the weekend. One thing is if you do an exercise, and we were talking about this before class, that Julian and I, if you do an exercise and you need a picture, you don't have to take a picture of the star or whatever. You can take a selfie, okay, and make it part of your report, okay?
I have a thought. Can we get an extra sheet for the map because it says to turn it in for the constellations
Yeah.
and stuff? But I like to keep the one and kind of
Yes.
keep track of what I'm.
You can have this one, and I've got extra ones at my office, so I'll kind of have a pile in case you want an extra one, let me know.
Oh, I can.
I think I might start an extra one next class.
The next one, next class? Okay. And also, the address is on there too.
Oh,
It's
so
stuck.
is that where you got it from?
Yeah, yep, skymapsplural.com.
Okay.
So, okay?
Good discussion. Oh, hard.
Hey, you got my email, right?
Yeah, and you
Okay.
are,
Megan.
yes, I did.
Okay.
Very
Okay.
good.
Okay. Just turn in chapter 3 for next week then?
Yep,
Okay.
wait, yes, that
Okay.
sounds right.
Okay.
Thanks.
Thank you.
You're welcome, thank you.
Oh my goodness. So it was stuck on you.
So are you thinking about the telescope, or?
I thought about it.
Yeah. I don't want you to save too much money, but that's okay.
But it's probably gonna be the cheapest you can get.
Iowa City in one of the middle things.
Yeah.
Everything with it. It comes with like a cell phone thing, I suppose being a microphone.
See, now I love it.
So, I'm thinking about it, 'cause it's not, it's like, if not, I can just re-gift it to somebody as a Christmas present.
That's true.
Just put it all in the box.
That's true. That's neat. Well, I look forward to hearing about it,
Oh,
if you do that.
if I decide.
Okay. Thank you, ma'am.
I can't believe this stayed warm for so long. That's awesome.
I know, I love it. I think the germs love it too, though, so
Yeah, I know. That's the only bad
no
part.
hard frost and stuff like that, yeah.
Does this get into physics, why the
I'll see you
seasons
later.
change?
Okay. The seasons change. The other part, and we're going to kick off with this on Monday, is have you ever heard? You should try this out. If you hold a flashlight, like, and it has to be one that emits heat. If you hold a flashlight like this, okay, kind of directly above something, your hand's going to get hot. If you keep it the same distance but hold it at and I think your textbook might do this. If you hold it at an angle instead. Okay, basically what's happening is that beam of light is going to be spread at an angle. Instead of small like this, intense, it's going to be spread at an angle. It's going to be lobbed out, okay? And that's kind of one of the things about seasons. Have you noticed, like, in the winter, does the sun get higher at noon or lower at noon?
Lower?
Lower, yeah. So in the winter, you kind of see it go across the nighttime, daytime stuff. And it goes, rises in the east and sets in the west. Okay, and around the summer, it's higher in the sky. And that kind of goes back to the flashlight. If it's higher in the sky, it basically, it has what we call less beam spreading, it's more intense. Okay, at noon. Whereas noon in a winter day, you go out noon in a winter day and the sun's about like this in a winter day. So basically that light is kind of spread over a farther, more of a region on the Earth's surface. And so it's an angle thing. That lower angle, instead of a higher angle in the summer, that lower angle in the winter, basically it makes the places on Earth where the sun strikes it, it doesn't get, the heat is not as intense.
Oh, okay, I see, they're saying. Yeah, because more of it bounces off sort of the less or more the angles.
Yeah, in the summer, when it's high, basically, you have, if this is my light, okay, basically that shaft of light hits the Earth's surface and it's like this, okay? And in the summer, if this is the Earth's surface, I have a lower sun, okay? And that kind of maybe what you were saying, the shaft of light is going to be kind of like ovals spread out. So this, I'll call this A1 and I'll call this A2, okay? So the area for 1 is less than the area for 2. So basically you have the same energy basically spread out more. So these guys, this is going to be cooler for every spot on the circle that it hits. Yeah.
So that's why we get seasons.
Yep. daylight hours. So our daylight hours have decreased. Okay, and it's a,
So I was trying to imagine, like, if I just, like, had a lantern maybe, I just took a ball around it,
okay,
like, tilted it at 23 degrees. I don't know. I have to go figure
Mhm.
this out.
it's interesting.
Because I feel like, because there's so many rotating.
Yeah, the Earth is rotating, but basically whatever the sun is doing for that day is constant throughout the day. I mean, I know the sun is also moving, not the sun, excuse me, the Earth is moving a little bit, so it is changing a little bit, but 24 hours basically you have the same configuration. So as the Earth spins, whatever the angle is, it stays the same.
Because I feel like both sides of the earth should, get the heat. The same thing should happen because the rotation.
Right, both sides of the Earth at that same latitude. Now, if you go change latitudes in different hemispheres, they got something else going on at that time of the year with that sun in that position.
Yeah, what up, Clay?
Earth and sun in that configuration. So you're right. I think you're right in that, so basically, if this is us, okay, and let's go ahead and put us at winter, okay, you're right in that everywhere, let's just kind of take this, okay, everywhere along here-ish is experiencing the same thing, same thing. But what point I was making is, if you go in the southern hemisphere, about the same latitude south instead of north, as the Earth spins, these guys are not equal to these guys.
Because the sun is, so as the next day,
Everybody knows there's flat
so this is.
The Flat Earth Society. God, I love those
So
guys.
that's good, you're holding your hand, and you are the sun, and,
pretty sure it was actually.
Okay, I
Yep.
see. The sun's more
right,
fried, and
it's more direct, more angled up here.
and then we come over.
That's where they were.
Yep.
Here,
Yep, exactly.
okay, it's more direct.
No, they did.
Yes.
We didn't help.
Very
It
good.
was all good.
We were just the
Good for you,
slaves.
Ty, now explain it to everybody else.
Hey,
Good
Ty,
job.
son, my technology.
Oh, that can't be good.
Dang it!
Big pile of rocks on top of each other.